Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Azmi bin Zulkifli, and today I will be presenting method of approximate estimation from DBT 362 Builder Economics to Dr. Izzat Fahmi. Okay, so let's begin the presentation. Okay, so these are the contents in my slides. First one being introduction. Second is methods of approximate estimating. The third one is advantages and limitations of approximate estimating. The fourth one is method application that is used in the drawing. And the last one is the conclusion and recommendations. Let's move on to the introductions. Okay, so let's begin with the introduction. What exactly is approximate estimating? Essentially, it is a preliminary assessment of a project's potential cost calculated well before detailed designs or final engineering plans are completed. It relies heavily on historical data, similar past projects, and broad parameters to find a realistic baseline. Why is it so important at the early stage of construction? Okay, first, it serves as a crucial feasibility check, determining whether a project is financially viable before stakeholders commit major capital. Second, it aids in risk management by identifying potential budget overruns early in the game. Finally, it ensures resource optimization, allowing developers to allocate appropriate funding and manage cash flow expectations right from day one. Okay, let's move on to the methods of approximate estimating. Let's start with the unit method. This approach determines the project cost based entirely on functional units, such as the number of beds in a hospital, seats in a cinema, or students in a school. The calculation is very straightforward. We simply multiply the total number of units by the cost per unit to arrive at a quick baseline figure. Next is the cubic method. Unlike the unit method, this technique evaluates the cost based on the total volume or the complete three-dimensional space of the building. To find the total cost here, we calculate the building total volume in cubic meters and multiply it by a predetermined cost rate per cubic meter, allowing us to factor the building site into our initial budget. Okay, the third technique is the floor area method, which happens to be the method we apply to our specific project scenario in this presentation. This technique calculates costs based on the total built-up floor area, reflecting the two-dimensional footprint of the building across all its levels. Our calculation formula here is the total floor area multiplied by the market rate per square meter. And the last one is story enclosure method. This more detailed technique calculates project costs based on the total vertical surface area of the building structural enclosure. To, to determine the budget, the total calculated enclosure area is multiplied by a standard rate per unit area, offering a quick way to weight different structural components, especially in a multi-story vertical build. Now let's move on to the advantages and limitations. Let's start with the unit method. It is extremely fast and simple because it bypasses architectural details entirely. This makes it incredibly easy to understand and calculate with minimal initial data. It works exceptionally well for repetitive projects like housing, schools, and hospitals, where the cost can be easily predicted by population or capacity. Next, the cubic method is highly effective because it directly accounts for building height and volume rather than just a flat footprint. This makes it particularly applicable to industrial buildings or warehouses where height significantly impacts the overall cost, helping stakeholders accurately compare expenditures between similar structural types. Meanwhile, our chosen technique, which is flow area method, is highly consistent for comparing projects of a similar nature. Such as standard retail developments, it is quick and straightforward for early cost assessment, allowing quick budgeting decisions for residential, commercial, and institutional projects without needing finalized engineering draft. Finally, the story enclosure method provides a fast way to estimate costs for a multi-story building by focusing on external walls, It remains easy to calculate with basic outer dimensions and is uniquely useful for specialized builds like office tower and apartment blocks. Okay, let's move on to the disadvantage and limitations. Okay, on the other side, we must carefully consider the structural limitation. For the unit method, it suffers because it completely lacks design detail and ignores the physical shape of the building. It is also highly dependent on historical data, which makes it highly inaccurate if you're dealing with a unique, modern, or mixed-use builds that don't fit standard historical templates. As for the cubic method, it does not differentiate cost distribution, meaning a cube of expensive office space is treated similarly to an empty plant room. It can easily mislead estimators on height factors and requires precise early dimensional data to be of any real use. Moving on to the floor area method, its primary drawback is that it completely ignores ceiling height and volume, assuming every floor is a standard height. It is completely blind to building plan complexity, such as curved walls, and fails to account for premium internal finishes or expensive mechanical services if they aren't explicitly specified. Lastly, the story enclosure method can quickly become time-consuming and complex to calculate compared to the other basic area methods. It requires advanced design data regarding the building's facade and relies heavily on subjective weighting factors that can introduce human error into the estimate. Okay, now we move on to the main focus of our presentation, which is the method application for the project that is proposed. Okay, the method that we use in this presentation is the floor area method. Based on current Malaysian construction cost data adjusted for the Terengganu region, which is Kuala Besut, that this building is located at, the average cost rate for a standard two-story shop office is approximately 1,400 ringgit per meter square. Now let's move on to the detailed calculation. Okay, so here we have the ground floor plan for the proposed building. Okay, so the first step of the calculation for a floor area method is we need to account for the width and length of the building. First, let us find the length of the building, which is this number here at the top, which account for the length. Okay, so these are the length of the building. So we can then took the numbers that we got from this and we bring them out here. Okay, as you can see, the length of the building consists of these numbers from 8,200 millimeter plus 6,096 millimeter and plus the same number triple times, and then we will get a total of 26,488 millimeters, which will then convert to meter to 26.488 meters. Okay, after that we are going to find the width of the building, which is located right here, and then we just bring out the number. It is already been totaled over here. So the width of the building is 21,873 millimeter, and we convert it to meter again, 21.873 meter. Okay, and then after we get both of the length and width, we can then multiply it so that we can get the floor area, which is like this. So the total floor area is the length of the building times the width of the building. We get the answer is 579.37 meters square. So this is the total for the ground floor plan. Now let us look at the first floor. Okay, as you can see here, it is essentially almost the same as the ground floor. So we just did the same type of calculation and the same method. The first one being we find the length of the building first, which is the one on the top here, and we bring it out, which is still the same as the ground floor. And next is the width of the building. which is this one, and we just bring out the number. It's already been listed there. So we got here. Okay, so this essentially is still the same as the ground floor. So we just did the same technique again, which is the floor area. So to get the floor area, we just time length time the width, so we can get the answer, which is 579.37 meters squared, which is still the same as the ground floor. Okay. Okay, so now let's look at the estimated project cost from the numbers that we got earlier. The first one is the total gross floor area. So we just what we do is we just total the ground floor area and the first floor area. We just add up the both of this area, and we get 1158.74 meters squared. So that is the total gross floor area. And after that, we can get the estimated project cost. So using the market rate of 1,400 ringgit per meter square that we get earlier per two-story shop office in Kuala Besut, Terengganu, we get the estimated project cost as the total gross floor area times cost rate. So we times the total gross floor area that we got earlier with the market rate of 1,400 ringgit per meter square, and we get the answer. We get a total of 1,632,236 ringgit as our estimated project cost. Okay, so now let's look at the estimate reliability of our calculation. Okay. First, regarding geographic location and logistics, we can count on regional predictability. Because Kuala Besut has a well-established supply network from neighboring hubs like Kuala Baru and Kuala Terengganu, material delivery timelines and transportation costs can be anticipated with a high degree of confidence. Second, when considering inflation and market volatility, our calculation uses a solid stability baseline. Utilizing 2026 economic indicators provides a reliable, forward-looking price anchor that safely absorbs the standard market shifts much better than relying on outdated historical data. Third, looking at material cost and specification, this estimate reflects a sense of standardized realism. The floor area method aligns perfectly with a standard two-story shop office layout, ensuring that our benchmark cost rate accurately matches the structural and finish requirements shown on the plans. Finally, for site condition and omission, we achieve a comprehensive footprint by calculating the entire progress floor area from the complete perimeter dimensions. This estimate successfully captures the absolute structure core and scale of the entire investment, making it a very strong starting point for the project. Okay, lastly, let's move on to the conclusions. Okay, so to wrap up my presentation, let's look at the conclusion and the key recommendations. As a key findings, the floor area method emerges as the best overall approximate estimating approach because it strikes the perfect balance between calculation speed and baseline cost accuracy for this type of commercial project. To improve estimating accuracy moving forward, I have three main recommendations. Okay, so as we can see here, firstly, we must regularly update cost database. It is critical to ensure all historical cost indices, inflation rates, and local market trends are updated continuously to stay relevant. Second, we should combine with site-specific adjustment. We must always factor in separate allowances for unique site variables such as specialized foundations or the external drainage works we saw on the layout. Finally, we should conduct cross-method verification. It is wise practice to use secondary techniques such as the unit or cubic method to quickly check and cross-reference our primary flow area estimate, flagging any message discrepancies early on. Okay, so that brings me to the end of my presentation. Thank you for watching and listening.